Even climate scientists cannot agree on how to compare different greenhouse gases, but I'll try to give you some idea of the discussion. This topic might seem a bit dry, but bear with me because this is a topic that is a main part of the animal emissions controversy. Greenhouse gases are removed from the atmosphere in very different ways. This graph shows how much of each gas remains in the atmosphere over time. The blue line is carbon dioxide, showing that in the first 30 years, the oceans and vegetation draw down about half the emission, then the remaining is slowly removed by rock weathering. Carbon dioxide has a lasting legacy. After 1,000 years, 10% of the emission still remains in the atmosphere. This is carbon dioxide's sting in the tail. Methane, in green, is very different. Most of the emission is oxidised from the atmosphere within 10 to 12 years. But while it's in the atmosphere, methane is many times more warming than carbon dioxide. There is also a lasting carbon dioxide residue from methane that's not shown here. Nitrous oxide, in purple, is an extremely powerful greenhouse gas, and it's removed over about 100 years at a fairly constant rate. So how on earth do we compare warming from each of these gases? Well, the most common way of comparing them is using a measure called global warming potential, which is simply the warming or radiative forcing of each gas compared with carbon dioxide for a given time. This is a graph from the IPCC report of the warming caused by a kilogram of each gas over time. So to find the global warming potential for methane, we take the actual warming of methane compared with the actual warming of carbon dioxide. Note that the methane warming shown in orange is 1/10 of the actual warming from methane, just to fit it on the graph. So the warming from methane is 10 times higher than what's shown here. So the warming over time from methane is the area under the curve up to that time. For example, this is the area under the curve for 100-year absolute global warming potential. So to calculate the global warming potential, we simply divide the warming from methane by the warming from carbon dioxide. Here is a graph of that calculation, which gives the global warming potential of methane. So on the left, when you compare methane to carbon dioxide for a 100-year time frame, methane has a global warming potential of 28. But if we compare the warming over 20 years, methane is 84 times more warming than carbon dioxide. The IPCC has chosen 100-year global warming potentials as the standard for comparing gases. That was an arbitrary decision that does not have a strong science basis. So when you hear the term carbon dioxide equivalent, that is done using 100-year global warming potentials, which is 28 for methane. Right here is the major point of contention. So when the FAO report that livestock is responsible for 14.5% of global warming, they use this figure, 100-year global warming potentials. However, that averages methane's warming over 100 years, many times longer than it actually lasts in the atmosphere. So it's almost like buying a $10,000 car that lasts 10 years, but justifying the cost by saying, but that's only $100 per year over 100 years. It just doesn't make sense. Nor does it make sense for carbon dioxide, because we know that after 1,000 years, 10% of the carbon dioxide is still in the atmosphere. So 100 years is way too short to measure the warming from carbon dioxide. But it does make sense for nitrous oxide, because that lasts for 100 years. So this is why comparison is so contentious. And it makes a huge practical difference. A carbon tax based on 20-year GWPs would be 3 times more than a carbon tax based on 100-year GWPs. In fact, any carbon tax on meat would make it quite expensive. New Zealand is struggling with the metrics now in its bid to be carbon neutral by 2050 because it has such a large dairy industry. Producers are even objecting to 100-year GWPs, arguing for other metrics that won't hurt their profits. They want the government to use the newly proposed GWP star, for example, which minimises methane's warming, therefore lowers the tax or offset. So this discussion is not merely academic, And when Salish Rao produces a discussion paper arguing that farmed animals are responsible for 87% of global warming, he is using 20-year global warming potentials. The arguments for using 20-year GWPs that amplify the warming from methane are strong. Firstly, dangerous climate change is with us now, and methane is the only gas that can slow warming in the next few years or decades. Stop methane emissions and we will feel the impact within months. Secondly, steep reductions in methane emissions will buy us decades more time to get carbon dioxide emissions under control. Third, even if we stop carbon dioxide emissions entirely, business as usual methane emissions alone will drive us into 1.5 to 2 degrees dangerous warming. So which is correct? Conventional 100-year accounting or 20-year global warming potentials? Well, both are technically correct. If you want to know warming over 100 years from now, the conventional 100 years is correct. But if you're interested in warming in the next 2 decades, GWP 20 is the one I would choose.